Here's another one, Lenovo laptop. What model's this one? Looks like an Ideapad S340. No power on. I can grab the charge connector, which I have checked. It has 19 volts coming out of it. Pop it in the side, and we have no light, no power, no lights on this side, no lights on that side, none along the front. It's completely dead. So we've got some inductors here, some voltage rails, another one there, another one there, over here, and that one is probably the charger. There's the battery. I wonder if there's anything in the battery. It doesn't turn on, so I'm picking it's fully discharged. Definitely nothing. Over here's where our DC input. So let's look here initially and see if we have perhaps a short on the input or something. So if we go across positive and negative on the input, and we have 120,000 ohms, no worries there. So we'll do a quick check from ground to some of these inductors. Nothing there, there, there. 7 ohms. So that's alright. Processors are quite a low resistance. So that is okay as far as I'm concerned at the moment. That one is high, high, high. Very good. All the rails look good. So that's bad. Let's plug it in, see if we have voltages forming where we would hope. There's should be 3 and 5 volt as a standby rail somewhere. Okay, do we have, I've got our charger plugged in, so do we have 19 on the other side of the DC jack? We have nothing. It's fluctuating all over the place. Okay, so we don't have 19 coming in for some reason. Let's get a probe locked into ground so I can do this one-handedly. Maybe. How about that? And I want to wiggle the charge plug and see if it changes anything. So we've got, no, it's not changing anything. So it's telling me the charge is shutting down because something is causing a overload on it as it tries to power up. Let's see what's going on the other side. Oh, we've got a great big foil plate. Let's peel that back. That should do for now. We don't have a lot there, just some, there's a fuse, our input MOSFET. Alright, let's check our input MOSFET. We have, it's a bit hard to see, I suppose, you can see that. 1, 2, 3, 4 pins across the top. The same on the other side under the shadow. And we'll see if we have a normal diode mode reading across that. Which one's the gate? I think the gate's up the top left. There's our gate. Gate to either drain or source. Nope. Nope. We've got drain source. Ah. We have a short. A drain to source short. No short to ground, just a short on the MOSFET. Well, that will definitely do it. That will definitely do it. Unless there's a capacitor across those 2 pins. And it's one of those that have failed. Okay, let's pop that off. Let's just knock half the other stuff off with it while I've got the chance, and it's nice and hot still. And if we recheck our MOSFET, is it shorted? Yes, it is shorted. Awesome. Okay, and I will just bridge out the gate to make sure there's no charge on there, and make sure it's not just half activated. No, definitely shorted. Let's see what I have to replace it with. So what is this thing, you might ask? Well, the numbers that we can see on it are now stuck to the board with dried flux. Okay, but in a nutshell, it's upside down, B04N03. And if you go and do a Google search, you can see it's 30 volt rated and 75 amp continuous drain current, with a what have we got for an on resistance? RDS on of about 3 to 5 milliohms. So okay, what have I got here? Is a replacement. I've got one of these, which is 5301C544P, which is what do we call that? IRFH5301TRPBF. At least that's the part number that I got when I ordered it. And if we have a look at that data sheet, we have 30 volt, 100 amp rated, so it's more capable, and RDS on of about 1.8 milliohms. So that's actually what, half the resistance, easy. So this thing should run cooler and handle more current. Yeah, it's just transitioned, so I need to get my chip upside down. Give it a bit of a wiggle, make sure the solder takes. Hold it down on the board. And clean up. Make sure everything's solidified before you go rubbing around there. You don't want to wipe off a bunch of components. Plug in and test. It's cold enough. And do we have 12 volts on our, or sorry, 19 volts on our fuse? No, we don't. We've got 20 volts because that's actually what the charger does. So win-win. We've got coming through the MOSFET here, there's 20 volts, and of course they have to be on that side, and on this side we have 20 volts. So we have 20 volts heading out to the rest of our system. Let's reassemble and test. plugging in, and I don't know where, if any lights light up will light up, but I don't presently see any lights. It could be on the top side. We will once again show that we have 19, 20 volts in. There we go, 20 in. Do we have, is our battery charging? Let's check on the positive of the battery. Our battery is not charging. Well, that's okay for now. Baby steps. Maybe the thing needs to power on. Maybe the battery is absolutely stuffed. Let's see if it'll power on. Power on. Is it going to power on, or we still got nothing? We still have nothing. But at least we have voltage to the board. Let's see if we've got our standby rails, I guess. No rail there. These are processor rails. They should not be on yet. We have no rail there, whatever that one should be. Over here we have 3.3. Our EC chip is not really warm. Not really warm. I wouldn't expect it to be. There's no heat. Is there heat? Oh, there is heat up here. Is our battery charging now? Our battery's charging now. Well, that's weird. I noticed there's quite a bit of warmth around here. The input circuitry again. It's not as hot as it would be under a fault condition, but it's just lightly warm. And we have 3 volts. Do we have anything on this one? No. See, I would have thought we'd have a 5 volt, but maybe not. Then over here it's going to be our charger. There's our 11.4, which should go up over time, and it is. There we go, 11.41, 42, 43. So the battery is charging. That's a good sign. Maybe the BIOS had to go through some reset phase, because we did have, there's our BIOS backup battery. We did have that unplugged as part of unplugging this flex that went through to here, so maybe there was some kind of auto reconfig procedure that it just went through. Because it's good for the battery, I'm just going to let that charge for a bit and see if it turns on. But it does say it's an 11.4 volt battery, so that's going to work out to 11.4 over 3.8. That's 3 cells, so you probably fit 1, 2, 3. So that's probably 3 cells. That sounds about right. And 3 times 4.2, so it should reach about 12.6 when fully charged. Well, I did just notice we have got an orange light on down here. So let's see where it's at in the charge cycle. 12.2, so it's getting well charged. Let's see if this thing wants to turn on now. And just so you can see, there's the orange light. So I'm going to unplug it. I'm just curious as to whether, or how quickly it comes back on. Now it hasn't come on straight away, so that's interesting. I find that interesting. Normally they would. I'm just going to unplug it and we'll see if it comes on from the battery. Here we go. Ah yes, fan spin. Cool. Let's see if we have a picture. There we go. One picture. And we have sound and we have boot up. Now the little light on the side is blinking, which blinking white. The power light is blinking white, so it may mean that the battery's low. The indicator shows she's low. So let's plug in and see if it will charge now that it's actually turned on. Okay. No, it's not charging. So we definitely have a problem with it charging. It did start, but it's just not taking off right away. So we're going to have to review what's going on there, double check our work, and what's going on with the charging circuit. Let's double check our MOSFET. It seems to be shorted again. Why would it do that? Clearly, if something further down the line was drawing more than it should, and somehow it was able to charge the battery, but the other one it feeds into is not shorted. Nothing wrong with that. And we have no shorts on either side. Now this is, I think this is the input side, since this goes off to our system. And we'll test it again out of circuit just to be sure. Shorted! So the only reason that would short would be, yeah, I guess if there's too much overload on this side. But we don't have any overload at this stage. With nothing operating, there's no problem. We've got 10 megohms to ground. So there must be something that starts up later on that's causing an excessive draw. We've checked our all our inductors, all our voltage rails. There's no shorts there. There's only 7 ohms on the processor. What I don't know is, did the short happen after I pushed the power button? But we didn't have a charge light prior to that either. It just miraculously came on later in the game. Let's double check our lines. Some other MOSFETs around here, make sure they aren't shorted, I suppose. They could be causing all sorts of things. May not short to ground, but a shorted MOSFET may dump too much power through to the battery. That's entirely possible. That's okay. I was just checking resistance before. I'll just check in diode mode now. Shouldn't matter. Wasn't shorted. So that's okay. Maybe the charge is good. They always put these blobs on, and that's to isolate the rail from the rest of the circuit. So I think this was our 3-volt supply. So they put that blob there, so you can take that off, and this should still function and create your 3-volt rail, and that would isolate the rest of the board to prove maybe if you had a fault on that line. But we had 3 volts, so we know there's no fault there. We do not have 5, and I don't know if we should, but usually they exist. They coexist. So I wonder if this should be 5. Let's double check on there. There's no low resistance there. 100k, unless this is like a MOSFET package, I think, so it can switch the rails on through to the rest of the system. So maybe we check the other side of that. So that's 50 plus k ohms. That's over 30k. So that's alright, that's alright, that's alright. Where else do we have such jumpers? Well, we've already technically tested those because, we test the coil and it goes through the jumpers. just back there where it went through a switch of some kind. Down here there's no switch, it just passes through, so that's all good. That one here, possibly a linear regulator. Let's just check that. So I've got 1.3 ohms, which is pretty much dead short. I don't know what rail this is, but no, it is a dead short. I didn't have a very good connection on the ring, that copper ring there, but no, that's a dead short. So we've got a switching regulator that has whatever rail that produces off that inductor. Let's think about this. This looks like the output to the processor. So this very well could be some kind of linear regulator operating off the side. They do that. Where does it go? Where does it go? Over here. If I check the other side of the board, no burn marks, but we can see where that feed comes through is here. Travels under the white paint. Actually comes back this way too. Comes through down here, down here, down here, down here. Oh. So this large trace running down through here comes to here. So I'll flip it over and see what's on that side. Aha. That goes out to our display panel. That's probably the display panel main feed. So now we've got to figure out why there's a short on that line. Actually, before I get too carried away, we always get battery voltage on the panel for the backlight. This is probably the feed in. This is probably the feed in from our DC in, which it would then make sense. That's where it's getting its feed to switch across the inductor, because it follows, it looks like it comes up here and along here and stops there. So we're going to check from, so we know it comes through from the charge connector through the MOSFET here, through this MOSFET. I wonder why this one doesn't blow, because it has to go through both. This is a resistor here, possibly a current sense resistor, but I don't see any lines coming off it. But it goes through there to the rest of the system. So we're going to check on here, and we'll check on where we saw it come all the way down to here to the display panel. See if it goes through there. Oh, what do you know? So we have our 20 volts coming through to here, but we didn't measure a short on that before. Why now? I'm getting very confused here. This point goes here. This point is shorted to ground. This point was shorted to ground. Why is it short when I push on it? What the? Just covered in goo. It's only short when I push on it. That's not good. That means if it gets flexed in the case, it's going to short. Maybe I should get the heatsink off. I mean, maybe we've got a fractured capacitor somewhere, but I need to get the heatsink off. And because when I'm pushing on it, of course the heatsink's on the board, and this is board's off the, it's held up off the deck a bit by the heatsink. So if I take the heatsink off, alright, what's happening under the heatsink? Anything out of the ordinary? No, the board's not going to flex as much now. Oh look, now it's a dead short and I'm not even flexing the board. Okay. Well, I should be able to find out what's getting hot as a result of that short. Right, let's see what happens when I apply voltage. What do we see getting hot, if anything? Where can we see heat? I see heat in the bottom left forming. It looks like a MOSFET for the CPU. That's odd. It's coming out of that MOSFET. It's coming out of this MOSFET. So ground and test. There it is. One shorted MOSFET on our main rail. I wonder why it was flexing, was giving it an issue. Was it actually surely not flexing across it enough? But this is the one that was getting hot, so let's remove that. It's going to be a bit trickier because these caps right there, we don't want to get that type of cap scalding hot. Might be able to do it from under the board or just remove the caps. What do you reckon? Just remove the caps? So we'll heat the board from the back and pop these caps off just to give us a bit of safety margin. Now, of course, we can come in and take our FET off. So let's verify that that is indeed shorted. See if our short is gone from the board. And it's not. MOSFETs, it's actually a twin MOSFET package. You can see, so there's one row of 3 contacts here, there's a gate pin there, there's another section and a separate gate pin, so it can switch between positive and negative in one package. You don't need 2 MOSFETs to do that. And this will be the same. So that's alright. So in theory, this MOSFET's okay. Yeah, we've got a 1/2 volt drop there, 1/2 volt there, so there's a couple of body diodes. I think that's fine. We still have a short on the board. What are we going to do about that? We need to find out what gets hot. So look what I found. Right on the opposite side of the board, so here's our 2 MOSFETs, but right on the opposite side is a little capacitor. I bet you that was what was getting hot and bleeding through to the other side, which is what looked like the heat spot. Instead of injecting voltage again, I'm just going to take that cap off and test it. This would also explain why it only shorted or stopped shorting when the board was flexing. Because of the way these are constructed, they are prone to flex, the effects of flex. Retest. Is our cap shorted? It is. And just to prove that, let's go ground to the capacitor. So you got one side ground and one side not. That's awesome. So this is on our 19 volt rail. So what I have is a 10 microfarad 25 volt rated. Make sure we get both ends to sit down flat. There we go. And like magic, it suddenly appears. Whoops, I forgot to start recording on that one. And of course, we want to do a quick check that we haven't created a solder bridge underneath the component, so we don't want that gate to be connected to the pins adjacent, which it's not, and I'm measuring here because you can see it comes around to those. We do not want it to be connected to the ones underneath, which it's not. Likewise there, and it's not. And we have that gate versus the ones beside it, all good. And that one versus that one, oh, that connects through to there. And that one versus those. And that's measuring about 4 ohms, but the board is still warm-ish. That's our ground. Ground was in the middle, wasn't it? Yeah, so it's ground to our output, which is 4 ohms. It was 6 when it was cooler. That one's 5. So I'm happy with that. We should be good to go. Let's get those capacitors back on. Warm the board up to encourage the solder to flow more easily underneath. There you go. Getting that down under there. Now we need to reattach our input MOSFET. There was an interesting little debate on whether, you know, if something goes wrong, do you charge the customer? And this could be one of those instances, which is up to your own judgment. But you know, you've got a bad part and you cannot identify shorts anywhere on the board initially that would you know, normally make perfect sense, and so you replace the part because MOSFETs are known to short just out of, you know, stress and exercise and whatnot, and so you replace the MOSFET, and then completely unexpected short down the track blows a new part again. So, you know, do you choose to wear that, or do you just bill it as parts required for the job? I think there's plenty of solder on there to sit another one on. You might weigh up the cost of going around and testing every single section of the PCB just in case you manage to find a short. I mean, that is time. Chucking a part on and having it fail again is a very quick way to tell you that you've got another problem. If I'm being honest, these parts cost me, what, 80 cents for the capacitor, and pretty sure it was that one there, so $1.50 for a MOSFET. You know, it's nothing. It really is nothing. $1.50 versus 20 minutes probing the entire board. You call it as worth your time or not. And of course it's all about speed when you're trying to do anything in this industry. Make money, you want to get the job done now. Do we have a short on our newly appointed input gatekeeper? No, we don't. Do we have our half volt body diode? We do. No gate source short, no gate drain short. Happy to go. Right, let's do this. First off, I'm going to test that the battery charges, so let's plug that in. And we're looking for a light on the other side of the board. So we should have our light down here. Here we go. One immediate orange light. So we know that things are a lot happier at the moment. Now let's see, is the battery charging? We should better make sure that it's charging. So is our voltage climbing? What do we say? 12.6? Yep. 0.01 increase is good enough for me. Can't sit here all day. We have our orange light by the plug, cool, and let's turn it on. Blinky light on the power button, what does that mean? We have a blinky light, I'm not sure what that means, but that doesn't matter. We have plugged in and charging. It could be that it doesn't know the battery capacity yet. I don't know. If I pull the plug, does it stay on? Yes, it does. Just had a look, and blinky light on the power button means that the battery is below 20%, and I'm not surprised. So let's let that sit and charge for a bit, and one more test and I think we're done. This is kind of cool. When it's off and charging, I think, what do I push, like enter or something? There you go, and it'll let you know how full it is. So we'll do one more boot up. Brilliant. And I can tell you that the power light is no longer blinking, so there we go, it's above 20%, doesn't blink. That's another one, guys. Thanks for watching. Any questions, comments, whatever, you know what to do. Catch you next time.